Hello students, welcome to the digital classes. Before we discuss anything, I want you to have a look at this. In Hindu temples, we see the Navagraha. From Sanskrit, the meaning is 9 for Nava and planet for Graha. This we often see in temples. So, what are these Navagraha? Before we see another interesting thing, let us see what we have discussed in the previous classes. We have discussed motion and rest, distance and displacement, speed, velocity, acceleration and laws of motion. In laws of motion, we have discussed Newton's first law, Newton's second law and Newton's third law. In this class, we will discuss centripetal force and the universal law of gravitation. Now children, observe the following. Here we have the days in a week. The left side you have in English, in Telugu and in Hindi. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Now let us see what these weeks are in other languages and in other civilizations. In Gregorian calendar, this is what we have: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. In Japanese, we have the same 7 days in a week, and in Chinese too. It is difficult to read, but what I want you to understand is there are 7 days in a week in Japanese calendar and Chinese calendar. Similarly, we have in Arabic, Greek, Zulu, Latin. Across all the civilizations, most of them follow 7-day week in all the cases. In almost all the civilizations, religions, 7-day calendar was followed. In Hindu calendar, Arabia, that is Middle East, Christian, that is Europe, Judea, Chinese, Japanese, Roman, Babylonia, Persia and many other civilizations also follow the same 7-day week calendar. Children, the most surprising thing in this 7-day week calendar is all the days are named after the planets and sun and moon. Let us see: Sunday for sun, Monday for moon, Tuesday for Mars, Wednesday for Mercury, Thursday for Jupiter, Friday for Venus, Saturday for Saturn. Now let us see what these Navagraha mean. Navagraha are Surya, that is sun, Chandra or Soma for moon, Mangala for Mars, Buddha for Mercury, Brihaspati for Jupiter, Shukra for Venus, Saturn for Shani, Rahu, that is north lunar node, and Ketu, that is south lunar node. Children, what I want you to understand is our ancestors have knowledge of these planets and celestial objects before they could actually see them through telescope or any other device. Just by looking at the night sky, people understood that there are planets which are different from stars, though both of them appear to be same in the night sky. Our ancestors from all the civilizations had the knowledge of the planets and their revolutions. Our ancestors knew that planets exist and they revolve. Only thing is, some believed that Earth is center of the universe and some believed that Sun is the center of the universe. Aristotle argued that Earth is center of the universe and convinced easily as stellar parallax was not observed. Children, Aristotle argued that Earth is center of the universe and he could convince people easily. Let me explain how it is. When we move across a road, if we see distant objects, they appear to be at rest or appear to move slower than the objects which are close by. The objects which are close by appear to move faster and the objects which are farther appear to move slower. Let me explain stellar parallax. Before that, let me explain what is parallax. Imagine we are moving on a road. The objects which are closer to us appear to move faster, whereas the objects which are farther appear to move slower. So, when we are moving, we feel that some of the objects are moving faster and some other objects are moving slower. This is parallax. And what Aristotle thought is, if Earth were to move, then we should also have the same feeling with the stars. Because stellar parallax was not observed, if we look at the night sky, we do not feel that stars are moving. We see them at the same places. Years together, we see the same pattern, that is the zodiac signs or the groups formations of the stars which are seen, the groups of the stars appear to be in the same place years together. So, this means that the stars are not moving, or we are not able to feel the parallax, that is the stellar parallax. Because we are not able to see the stellar parallax, Aristotle said that Earth is not moving, Earth has to be stationary. Using Aristotle's theory, that is Earth is center of the universe, Ptolemy proposed geocentric model which says that all planets, sun and moon revolve around the Earth. Nearly 1400 years this theory was believed, and later Copernicus proposed heliocentric theory which said Earth and all planets revolve around the sun. Galileo and Kepler supported the heliocentric theory. Imagine, children, a theory is proposed and because of lack of evidence, the theory was believed for nearly 1400 years until it was proved by mathematics and then later observations through telescope. It was Newton who could explain that all the planets are going around the sun because of gravitational theory. But it was Newton who gave proper reason for why planets revolve around the sun by his Universal Law of Gravitation with proper mathematical relations. Many of the astronomers were able to give an idea whether planets were going around the sun or sun was going around Earth, but nobody has explained why these revolutions occur, that is why planets will go around the sun. But it was Newton who could explain all this with his Universal Law of Gravitation backed by strong mathematics. Let us see what Universal Law of Gravitation says. Every object in this universe attracts every other object in the universe with a force directly proportional to the product of masses and inversely proportional to the square of the distance between them. This law explains why objects fall down. Let us write this law in equation. The force of attraction between any two objects is given by F is equal to G m1 m2 by r square, where m1 and m2 are the masses of the objects and r is the distance between them. Children, observe this carefully. Children, you have observed this video, but do you feel that it happens really? Any child will say that the video was played in the reverse. Children, I am going to show you a small trick. Observe this carefully. Here I take a card and let us see, I am going to make it levitate. Ready? Abracadabra. Now, you can see I have a pen. You can see that this pen goes under it. It is levitating. Watch it. It is levitating. The card is levitating in my hand. Children, there is no trick at all. I have fixed a small strip of plastic which is making it levitate. So, this is what is happening, but from a distance you can show that this card is levitating like this. Children, I would like to remind you that such tricks are not real. They are only tricks which create an illusion that things levitate like that. And remember, nothing happens against nature. things will not levitate unless there is some strong force. So, children, in this activity we have seen that no objects can go against gravity upwards or no objects can just levitate. All objects have to fall down. Children, I made a statement. I want you people to think and understand and ask a question. I repeat the statement. All objects fall down. Children, I want you people to think and imagine whether the statement which I made is right in all the cases or not. So, I repeat my previous statement, all objects fall down. Question you should ask, then why some objects like helium balloons fly up? Helium balloons fly up because their density is lesser than that of air. In other class, we will discuss on density and flotation, which object will float and which object will sink in fluids. But for now, just remember that in any fluid, if there is an object which is denser than the fluid will sink, and if the object which is lighter than the fluid will float. So, in this case, air is more denser than the helium balloon. So, helium balloon will rise upwards. And remember, it is not against gravity. Children, now I ask a question. If all objects are falling onto the earth and cases where helium balloon will rise up, that is also because of gravity, why does not moon fall onto the earth? I repeat the question, why does not moon fall onto the earth? Let us explain. Before I answer or before we study why moon does not fall onto the earth, let us study circular motion. According to the first law of motion, that is Newton's first law, every object continues to remain in its state of rest or uniform motion until an external unbalanced force acts on it. This means an object moving in a straight line should continue to move in the same direction unless an external force acts on it. Now, imagine an object which is moving in a straight line. This object is moving with a velocity in a direction, and until an external force acts on it, it has to move with the same velocity in the same direction. Now, let us say there is a force which is perpendicular to the direction of the velocity, and now the direction of the velocity changes. So, the object moves in other direction. Here the direction of the force is constant, and which results in the motion of the object in this way. So, as long as the force was acting, the velocity of the object was changing continuously. So, in this case the external force was constant and the direction of velocity was changing continuously. Now, let us consider the force which acts on the object in such a way that it is always perpendicular to the direction of the velocity. Here is an object which is moving in this direction. Let a force be applied perpendicular to it, its velocity changes. Let the direction of the force be perpendicular once again to its velocity, and hence the direction of velocity continues to change. If the force is always perpendicular, the velocity of the object continues to change continuously. So, if there is a force which is always perpendicular to the velocity of the object, then the object moves in a circle. Here always the force is perpendicular to the velocity. So, the object has moved in a circle. Force is always perpendicular to the velocity of the object as long as it was in circular motion, and force is always directed towards the center of the circle. This force which is necessary for an object to move along a circle is called centripetal force. Children, here I have a bottle there is some water in it, you can see, yes, there is water. Now, I am going to rotate this bottle, watch it, I am going to rotate, children, yes. So, not even a drop of water fell down. This is because the gravitational force which is acting on water is making it move in a circle, providing the necessary centripetal force. So, the water was moving in circular motion rather than falling down. Children, to understand centripetal force a little more in detail, let us demonstrate another activity. Here I take a barrel of a pen and then I use an eraser. I have a bottle filled with vinegar which is heavy, much heavier than eraser. You can also see, yes. So, this is more heavy, right. What I am going to do is, I am going to rotate this eraser, whirl it around, and then I am going to rotate it. So, you can see when this eraser is rotating, the necessary centripetal force required for the eraser to rotate is provided by the weight of this bottle. If I reduce the speed, then less centripetal force is required. So, the bottle is coming down. So, lesser the speed, lesser the centripetal force required. If you rotate with a greater speed, then more centripetal force is required. So, that is not enough. So, hence the bottle is being lifted up. It is fun, children, doing such activities, you can try at your home. If the centripetal force is constant, then the object moves in uniform circular motion. In uniform circular motion, the object moves with a constant speed, continuously changing its direction and each and every point of the path. Here if we observe, at each and every point the direction of the velocity is given by the tangent at that point. Children, if velocity changes, that means there has to be some acceleration which changes the velocity. So, let us derive the acceleration for the change in velocity of the object which is in uniform circular motion. So, consider 8 points. At these 8 points, we have drawn the velocities of the object, and now let us draw all the velocity vectors from the same point. That is, rearrange the vectors such that all of them start at the same point. This does not change the magnitude or the direction of the velocity. We can just redraw these vectors at different points. So, here I am drawing all the vectors starting from a point. And here is the last one. Remember, we can select as many velocity vectors as possible. I have selected only 8 velocity vectors. So, rearranging the velocity vectors give us the figure like this. Let us draw the change in velocity. So, here I select 2 vectors. I draw the change in velocity for the 2 velocity vectors here. Similarly, we can find out change in velocity for all the velocity vectors. If we consider a smaller time interval, the change in velocity tends to be perpendicular to the velocity vector. Smaller the time interval we take, smaller will be the change in velocity. At the same time, the change in velocity will be perpendicular to the velocity vector. Here the change in velocity is equal to length of the arc. If we consider change in velocity over one full rotation, that will be equal to length of the complete arc, that is circumference, which will be equal to 2 pi times radius, which is equal to 2 pi v. Change in velocity over one full revolution will be equal to 2 pi v. Acceleration is rate of change in velocity, and hence acceleration should be equal to 2 pi v divided by time taken for one full revolution. Speed is equal to 2 pi r by time taken for one full revolution, that is equal to t, let us say. So, v is equal to 2 pi r by t. Acceleration is equal to 2 pi v divided by time taken for one revolution. So, speed is equal to 2 pi r by time taken for one revolution, which comes out to be 2 pi r by time. Rearranging, v is equal to 2 pi r by t gives us t equal to 2 pi r by v. So, acceleration, which is rate of change in velocity, will be equal to 2 pi v divided by 2 pi r by v, which gives us v square by r. This acceleration is called centripetal acceleration, the acceleration which continuously changes the velocity of the object in order to make the object move in a uniform circular motion. From Newton's second law, we have learned that force is equal to mass times the acceleration. So, the centripetal force is given by mass times the centripetal acceleration. Centripetal force is equal to m v square by r. So, centripetal force is given by m v square by r, where m is mass of the object which is in circular motion, v is the velocity, r is the radius. Children, we have answered the question, that is why moon does not fall onto the earth. The gravitational force between the moon and the earth provides necessary centripetal force for the moon to go around the earth. Children, let us explain the centripetal force acting on moon, or which makes moon revolve around the earth, with this example. Consider a tower of a great height. So, imagine we are throwing an object parallel to the earth. This falls on the earth this way. Now, let us throw the object with a greater speed, which makes the object fall a little farther than the previous point. Throwing with even more greater speed makes the object fall much farther. If we keep increasing the speed, the object may fall something like this. The object may fall a little more farther. Let us say if we increase the speed further, there is a chance that the object comes back to the same point. At this speed, it continues to go around the earth and never fall onto the earth. This is how the moon revolves around the earth. Not only the moon, the artificial satellites also revolve around the earth because of the gravitational force. Let us look at the universal law of gravitation once again. Every object in this universe attracts every other object in the universe with a force directly proportional to the product of masses and inversely proportional to the square of the distance between them. Here let us say we have two objects, mass m1 and mass m2. The distance between the centers of the mass is r. The force of attraction between them is given by g m1 m2 by r square. Now, when I say every object, it means every object. It can be me, it can be you, it can be anybody. All things which have mass are objects, and each and every object attracts every other object in this universe. That means, I am attracting this object, the objects nearby, I am attracting this laptop. Here objects mean tables, chairs, people, spoon, trucks, rocks, etc. Anything that has mass interacts with another mass, and we have to remember few more points about this gravitational force. The gravitational force is always an attractive force. It is a long range force. It acts over distance of crores of kilometers. It is a universal law. It is a theoretical law, unlike empirical laws like Ohm's law, Boyle's law, which were based on experiments. Empirical law is made from the observations. We do experiments, we record, we see the observations, and based on those observations we generalize. For example, Boyle's law, which says the pressure in a gas is inversely proportional to its volume at constant temperature. So, experiments were made and the observations were recorded, and based on calculations generalizations were made, whereas universal law of gravitation is a theoretical law. Newton did not measure the force between earth and moon, nor Newton did not measure the gravitational force between sun and earth. It was only based on theory. Newton already has given laws of motion and uniform circular motion. So, based on these formulae and the only observation of revolution of moon around the earth, he could make the generalization that there has to be a strong force which can make an object which is massive as moon to go around the earth. We have to remember that universal law of gravitation is a universal law. Children, I want you to imagine, think, ponder how Newton was able to give the formula that force is directly proportional to product of masses and force is inversely proportional to square of the distance between them. How was Newton able to give this formula? Children, let us discuss the answer to this in the next class, but now let us revise. The force is always perpendicular to the direction of velocity and is given by mv square by r. Universal law of gravitation: every object in this universe attracts every other object in the universe with a force directly proportional to the product of masses and inversely proportional to the square of the distance between them. Force is given by g m1 m2 by r square. Children, what I want you people to do is take the textbook, go through the lesson, and if possible try to read some more books and discuss various examples given. Also observe many things which happen around you and try to give reason why they happen the way they happen and not the other way round. Also discuss various examples with your friends, and if you have any doubts, get them clarified from your teachers. Thank you.